Okay. Yes, thank you. Thank you again, everybody, for joining. We have a really good presentation tonight, AI agents for MBSE. Ivan Taylor will be presenting. Um, Before we get into the presentation, though, I want to just bring to everybody's attention a workshop that's coming up. I'm just sharing a PDF of this. I know it's not showing. It may not show the best on your screen. My understanding is it might be a little bit blurry in some areas, but I can speak to the points. So essentially, this is a transportation infrastructure workshop that would be held in Ottawa at the Rogers Centre just prior to the International Symposium for 2025. So this workshop will be on July 25th. It's an all-day event from 8:30 a.m. to 5 p.m. Eastern Time, that is, in Ottawa. And we have several guest speakers in a panel-like format. Um, the workshop is being put on by Incosi Canada chapter, as well as the Association or the American Public Transportation Association, APTA. We're fortunate to have some good sponsors. So Mott McDonald and JAMA Software are gold sponsors, and Parsons Corporation is silver sponsors. So a big thank you to those organizations for sponsoring the event. If you're registered, we hopefully we'll see you there. If you're not registered, you can contact Incosi Canada chapter, and there may still be opportunity to join if you're in Ottawa at that time. Um, I'll just share another screen here. No, it's actually no, it's just the same information. Okay. With that, I think we'll move on to the main event. So I'd like to introduce Ivan Taylor. This won't be Ivan's first presentation. He's blessed us with several presentations, and thank you, Ivan, for your hard work and contribution to our community. Ivan is the president and senior researcher at Policy Dynamics Incorporated, which was established in 2001. He has a master's degree in information and systems science and a PhD in public policy. Ivan has been involved in COSI for some time now, serving as a board member. He has an article, him and a co-writer, David Hetherington, have an article in the latest issue of the Incosi Insight magazine. So keep an eye out for that one. And Ivan has also presented at prior Incosi international symposiums, as well as international workshops for Incosi. Further to that, Ivan has participated with presentations for the social systems and the resilient systems working groups. So very involved. Your participation is very much appreciated, Ivan, and again, presenting for our Canada chapter is wonderful. So thank you for that effort. What we're going to do, I'm going to turn the screen over to Ivan for his presentation. And if you have any questions, please put them in the chat. Ivan will try to get to them at the end of his presentation. And Ivan, are you open to taking questions during? No? Let's hold off till the end. Yeah, okay. So let's hold off till the end. But that doesn't mean you can't be putting your questions in the chat. Okay, and please do that. And with that, I'll hand it over to you, Ivan.
Thanks, Ivan. Yeah, just a couple other things that I might want to let you know about is I'm also a member of the sustainability working group that's basically just started, but is very, very active. And I'll be talking at the end of the presentation about a case study I'm doing for the sustainability working group with this technique. And also, I have a paper that's being presented by a co-author at the International Symposium in Ottawa. So yeah, so I won't be able to make it this year to the International Symposium, but my co-author will be there. His presentation will be in the MBSE lightning round. I'm not sure if there's another name for it, but it's the MBSE workshop, and it's a lightning round presentation. So, and it's on integrating system dynamics with SysML v2. Okay, I'll get into my presentation now.
Okay, we see your Zoom screen. There we go. Good. Yep.
Okay.
Thanks.
Okay. Yeah. So the title of this presentation is AI Agents for MBSE. And what I was doing was I was connecting the processes in MBSE through workflow diagrams and using AI agents to actually help me with the processes. And and I'll show you how I did that. Just a couple of things. I guess you know I'm from Policy Dynamics. I'm in Kitchener, Ontario, um, and um, that's about it, I guess. Anyway, so the purpose of this purpose and objectives is to introduce AI-driven MBSE approach um, that will connect the MBSE processes via workflows. And by doing that, we will enable agent-based integration, AI agent-based integration. So I'll start with the introduction and background. I will then get into an MBSE process overview, and then I will get into the detailed MBSE workflows where I'll spend most of my time. And then I'll talk in the end about AI agents and in the MBSE workflows. And then I'll have a little summary at the end. So this presentation was sort of initiated by a Reddit thread that was entitled "Is MBSE Dead?" And it was started off by a fairly experienced MBSE analyst, systems engineer, who was quite critical of MBSE after working with it for a number of years. It led to a very interesting discussion, and I'll just highlight basically what was said. But this is in Reddit, and you can look it up. It's called "Is MBSE Dead?" And the author said that MBSE is overhyped and that the core tool chain is costly, dated, and error prone. SysML has a steep learning curve, and failed integrations force data duplication, eroding a single source of truth. And there were no usability breakthroughs in sight. So this was a challenge to us at all, I think. And I took up the challenge by looking at the possibility of AI-driven MBSE and whether this was a breakthrough that maybe is in sight. And so my feeling is that AI-driven MBSE can transform MBSE from static documentation to a live digital thread, and that natural language model generation can slash SysML v2 learning curves. And SysML v2 can give AI the structure it needs for automation and traceability, and smart integration of AI can help sync data without duplication. And AI agents can continuously do consistency checks, impact analysis, and decision support. So I don't think I have to tell you this, but I'm going to go through the the MBSE processes, and I'll just go through this quickly. This is the top level view. Um, we all know we start with conceptualization, which is maybe the most important phase, and that leads to needs and mission definition. And then we have requirements definition comes next with the system requirements baseline. And then we have architecture definition with architecture models and interfaces. And then we get into design with detailed design, trait studies, and executable models. Then verification and validation with test cases and the V&V plan. And then integration and test where we verify the system and we have issue reports, which may lead back to changes in design. And then we have implementation support where we coordinate with builders and developers. These are the phases I'm going to go through today. There are a couple more phases. There's operations and maintenance, which is, of course, very important, but I'm not going to go through that. I do have the processes linked, but I haven't gone through the AI generation work yet. And then, of course, there's retirement and decommissioning, and that's another important phase, especially in the area of sustainability, where we're looking at circular economy and things like that. So I'm not going to go through those other phases today, but I do have the task list that I'll show you identified for those phases. Okay, so I'm going to go through the workflow and I'll show you how I connected the processes in the workflow. So in conceptualization, you probably already know that we identify stakeholders, we elicit stakeholder needs, we analyze and structure those needs, we define the mission, we identify the success criteria, we define use cases, we draft an operations concept, we identify system boundaries, we define external interfaces, we identify initial risks, and we prioritize risks. Now, what I did was I broke the process of this conceptualization into a number of tasks. And here I have the tasks identified, and there's 27 tasks that I identified in the conceptualization workflow. And what this table shows is that we have each task is identified with a number, and then there's an input to this task and an output to the task for the task. And then the output for the task leads to an input to another task. And so in this case, we start with strategic goals, and we end up with a lot of artifacts that come out of this, and we end up with say use cases and parametric models and the operations concept. So I'll just show you. I'll just run through one of these workflow situations. So we start off with strategic goals, and from there we get a comprehensive stakeholder list. And then with this comprehensive stakeholder list, we develop a stakeholder engagement plan. And with the engagement plan, we identify stakeholder goals. And then we develop a mission statement from the stakeholder goals. And then we identify success measures from the mission statement. And then we identify key performance indicators from the success measures. And we develop parametric models from the key performance indicators. So that's an example of a thread that goes through the conceptualization workflow. And I have a diagram which shows the conceptualization workflow. It's of course it's impossible to read because the writing is so small, but you can see here strategic goals leads to the initial stakeholder list, leads to the comprehensive stakeholder list, and then we can see that that leads to a number of other activities that come out of the stakeholder engagement plan. And in particular, the stakeholder engagement plan leads to stakeholder goals, leads to the mission statement and the success measures, the performance indicators, and the parametric models. So each of these arrows is an artifact, and each of these yellow squares is a process or a task. And so this is what I've done. And so basically stakeholder goals starts the whole thing, and you run through the conceptualization phase with doing all these different tasks. And then the outflow from the conceptualization is shown in these arrows that just go out of the conceptualization stage into other phases of the workflow. So if you think about how this works is I start with a prompt that I'm going through. I give it the task list, and I say I'm going through the MBSE process one step at a time to design a product. I have a couple of case studies, and one of them is an ethical photovoltaic system for generating power, and another is a wearable medical device for diabetes. So I say I'm going to design this product, and then I take the input from one of the tasks, or the input, and then which is an output from one of the tasks, and I say, please conduct a task that converts the input into output. And then I ask it to do that in natural language so I can inspect the results. And then when I'm happy with the results, I can validate the output that it gives me. And then I can prompt again and say, provide this output in a downloadable SysML v2 metamodel compliant code file. And then I can save the file. So all the work is done. Well, it's done in natural language, first of all, and then it's done in SysML v2 for final saving. So then we can go through the requirements definition workflow, where we identify the system level requirements, we decompose the requirements, we classify the requirements, we allocate requirements to functions and components, we ensure requirements traceability, we validate requirements with stakeholders, we identify constraints and assumptions, and we document requirements in a modeling tool. And so here's the tasks that I identified for the requirements definition. There's 21 tasks, and it all starts with structured needs list from the conceptualization phase. And then we go through the high-level functional requirements and non-functional requirements, and so on through various preliminary architectures, and then use cases and we end up with validated requirements, and we put those validated requirements in a requirements repository. And here's the process. And here you see that we have these boxes outside or starting the process here. And these boxes are processes from the conceptualization phase, and they lead to outputs from conceptualization phase, which then start the processes of the requirements definition phase. And so you see that we then go through the requirements definition phase and have outflows to later phases of the workflow. So you can think here of how AI might be used with requirements definition. So we could, for example, paste the stakeholder needs document into the AI assistant and let the AI assistant parse it and populate the model with structured requirements, each traced to a stakeholder need. And then we can get the AI to suggest missing requirements or clarify ambiguous statements. And this might save hours of manual data entry and ensure that nothing gets lost in translation, improving efficiency and reducing human error. Okay, the next phase is the architecture definition, and we perform functional analysis, We define system behavior and states. We develop architectures, physical and logical. We allocate requirements to architecture. We conduct design trait studies. We define interfaces, internal and external. We refine and update architectures. And we have a baseline architecture that comes out of this workflow. And here's the processes or tasks in the architecture definition workflow. And there's 24 tasks, and it all starts with validated requirements and leads through the various architecture to artifacts and comes out with a consolidated architecture data, which leads to a complete architecture model. And here's the workflow and a diagram, and you can see that it's much more extended. There's a lot of links from one process to another, but it all starts here with the structured needs, with the validated requirements. Okay, so that's the architecture definition. And then we get into the design workflow where we develop detailed component designs. We refine internal interfaces. We create executable models and prototypes. We perform design analysis. We verify design against requirements. We conduct design reviews. We finalize the design package. And here is the processes. There's 24 tasks in the workflow, and it starts with the physical architecture, and we drill down into components and end up at the end with a design documentation package with valid design models. And if we look again at the workflow, we see this sort of pattern of activity going through the system, and it all ends up with the design package down here and the updated traceability matrix. And then we get into the verification and validation workflow, and we establish the V&V objectives. We define verification methods. We define validation scenarios. We develop test cases. We map requirements to test cases. We plan simulation-based testing. We identify test data requirements, and we document the V&V strategy. And here's the processes. And there's 14 processes in this verification validation. And it starts with the structured needs list from the conceptualization phase. And then it goes through the verification validation objectives, which lead to tests, validation scenarios, test cases, requirements to test matrix, and test data requirements, and so on. And then we have the workflow. The interesting thing about this workflow is that the initiating processes come from many different previous phases of the workflow. So for example, the first two here come from conceptualization. This one comes from requirements. These two come from conceptualization. These two come from design. Oh, these two come from architecture. And then so you can see that we have many different connections between the phases with the verification and validation workflow. And then we have integration and test workflow, where we plan the integration sequence, we assemble the system components, we execute test procedures, we record and track test results, we identify and log defects, we perform root cause analysis, and we update system models and conduct regression testing. And here there's 16 tasks, and it starts with physical architecture and drills into the test cases with various reports and logs, and gets into root cause analysis and corrective measures. And those corrective measures require updating of architectural models and behavioral models. And then we have regression test cases and regression test reports. And here's the workflow. And you can see a very long string of tasks that go through the test cases and the defects reports and end up with regression tests. And then we have the implementation support workflow, which prepare implementation packages, support code generation and or handoff, coordinate with builders and developers, support hardware in the loop and software in the loop testing, capture implementation feedback, resolve interface discrepancies, manage configuration baselines. And here's the tasks in implementation support. And we begin with the design documentation package. And then we have a we generate a build package, and we go through with supporting the builders and the developers, and we get developer inputs, and then we can use that uh, to get feedback and possibly make design change requests, and then that might lead to updated designs, and this would then loop back into updating the interfaces, into updating the design models, and then we have a design change request leads to a change history. And so this idea leads to some looping back to previous processes, and that can be a place where AI can be really helpful. So this is the implementation support workflow, and then so now we can talk about how AI can be really, really helpful here. A team member can ask the AI which system functions would be impacted if requirement X changed. And then the AI agent can instantly traverse the model and respond with the affected functions, components, and test cases. And this can demonstrate traceability and impact analysis without manually digging through the model. And SysML v2 is critical to this AI-driven MBSE idea, because SysML v2 provides unified semantics to let the AI reason over models reliably. And the inputs and outputs are machine recognizable. And the SysML v2 text format enables automation. And you have one schema that spans all phases of MBSE. And you have built-in traceability, which supports impact analysis. And here's some examples of the traceability. So we have some concept to requirements. You have the needs become requirements with AI-ready trace links. And then we have requirements to architecture and design. We have satisfy and allocate, which expose links for agent validation. And then we have design to V&V, where we have test cases and verify, and agents can auto-build the test cases. And then integration and ops, we can measure the operations, and that can bind the runtime data with real-time digital twin updates. And so we have through SysML v2, we have a digital thread where one SysML v2 repository flows outputs across the phases with no remapping. So as sort of a little bit of a summary, you can think of AI agents as 24/7 junior engineers. They are junior engineers, and they have to be supervised. So, they're not replacing system engineers. They're supporting them, and they're tireless junior engineers that can handle the grunt work. And for example, they can continuously run consistency checks, update trace links, generate routine documentation, and draft parts of specifications or interface control documents from the model. And for example, if an interface changes, the AI could automatically update the related descriptions and notify the team. So this ensures that the MBSE model and the documents are always in sync with minimal human effort addressing integration and consistency issues. I have a couple of case studies, and we may have time to go through them a little bit if you want. The first one is a wearable medical device to support type 2 diabetes lifestyle change. And in this example, I have a team of people I'm working with, and we've gone quite a bit into the MBSE process using AI agents. We've gone through conceptualization, requirements, architecture, and design. The strategic goals were to improve adherence and glycemic outcomes and provide a personalized and intuitive user experience, integrate validated data across care providers, and support value-based care through a secure platform. The other case study was for the sustainability working group, where we were looking at an ethical standards-based solar power system. And in that example case study, I've only gone through the conceptualization phase. But the strategic goals are to exceed IEC and IEEE and ISO standards and deliver reliable, low-cost renewable power, cut emissions, and support the circular economy, ensure ethical sourcing and fair labor, and create lasting value for all stakeholders. So my answer to the question, is AI-driven MBSE a breakthrough, is that AI-driven MBSE transforms MBSE from static documentation to a live digital thread, and that natural language model generation can slash the SysML v2 learning curve, and SysML v2 gives AI the structure it needs for automation and traceability, and smart integration can sync the data without duplication, and continuous consistency checks and impact analysis and decision support can be done with AI agents. And I think that AI-driven MBSE can be a game changer. So that's my presentation. Thank you for your attention, and I'd be happy to try to answer questions at this time.
Thank you, Ivan. I have a questions. I didn't ask them on the chat. I hope it is okay if I ask
Go
them
ahead.
live. So maybe first question is how do you ensure that AI is not hallucinating when answering questions on the models that have been created by the AI?
Yeah, well, we start by basically having guardrails that basically keep the tasks clear, and trying to use just the information that is available in the inputs to produce the outputs. So it should be traceable, and therefore that should avoid hallucinations a little bit, and the other thing is, like I said, we supervise it, so we produce the results come out in natural language, and I can validate those results by reading the natural language output, and then I ask it, once I'm satisfied with the natural language output, I can ask it to generate the SysML v2 code. So it's highly supervised. It's not, like I say, it's like a junior engineer. You ask it to do something, and then you look at what they've done, and you correct it, or you ask them to change it, and then once you're happy with it, you can start to put it into the database.
I imagine that good prompt engineering is important here, and something that you would just refine over time.
Yeah, I think that, my feeling is that there's a lot of tasks that I've identified, and it
Hmm.
breaks down the whole process into smaller pieces that are manageable by an AI, rather than, say, asking it to generate a lot of material that maybe would allow them to escape and hallucinate.
Yeah, good question, Stefan. Thank you, Ivan. We have a question, will the slides be shared? And the answer to that one is yes. You will be able to find, well, actually, the slides, that's a different, the recording will be shared, and that will be on the NCOSE Canada chapter website. Now, the slides, Ivan, will they be shared?
The slides could definitely be shared. I don't know the best way to do that. Um, uh, I don't know, do we have a registration list that we could send them out as a bulk email?
Yeah, we will have a registration list. So, yeah, I'll look into that, getting the slides sent out. But what I suggest, the invitation that you had received, perhaps you could respond to that. Anybody who does want the slides, respond to that, and we'll have your email address that way and be able to send it to you.
Yeah, you can also contact me directly
There you go.
at Ivan@PolicyDynamics.ca.
That might be the best.
Another thing I should say is that when I do recordings of presentations, I always post them on my LinkedIn page.
Hmm.
And so if you want to reach me on LinkedIn, you can either review the presentation, or you can connect with me and ask me for the slide deck, and I can send it to you that way. So I'd love to connect with you on LinkedIn, and I think that's a great resource for communicating.
Very good. Yeah. So I think LinkedIn or Ivan's email address on the screen right now. I think that's the best way if you want a copy of the slides. The recording will automatically will be placed on the NCOSE, not automatically. Stefan's the one that does it, but it'll be on the NCOSE Canada chapter site. Another question is just asking, which AI did you use? Was it ChatGPT or something else?
No, I used ChatGPT 3.0, which is
Okay.
which
Three.
is
Okay, not four.
a slightly more sophisticated version of ChatGPT that does a little better job than 4.0, and also the issue I had with it is that you, even with the paid subscription, no, I don't know if it's, I guess the paid, the basic paid subscription, you're limited in the number of inquiries you're allowed to have per month. So, I was going through this process, one task at a time. And after a while, I reached the limit and I was doing, of course, multiple case studies. And so eventually I reached the limit of my queries, and I had to wait a few days for it to reset.
Mm-hmm.
I don't, 4.0 doesn't, I don't think has that issue, but I think 3.0 is a better tool for this.
Interesting. Okay, good. Thank you. Adam asked just an extension to a prior question. Did you use an AI trained, let's see, did you use an AI trainer, I guess, for systems engineering? Or, did you use an AI that's trained for systems engineering?
Well, not exactly. Like I said, I loaded up the task list that I generated. So basically, every time I had a query, I would load up the task list. So I guess in that small way, I was able to train ChatGPT on what is required for systems engineering and model-based systems engineering. So, basically, and that task list I generated from NCOSE sources.
Okay, good. Next question. How do you provide additional domain-specific context to standard AI models? Do you implement any RAG systems for the large language models that provide specialized knowledge for SysML v2 and other system engineering concepts?
I didn't do anything for domain knowledge, but I did do RAG work with queries in terms of like I said, go if you like I said when you if you let's say you change a requirement or change an interface, I was using RAG to find the impact of that. So I wasn't using anything specific about the domain area, but I was using basically RAG to to help me with the traceability.
Okay. Good. James says, thank you, Ivan. In your view, what would be the best way to mitigate current shortcomings of AI while at the same time trying to maximize its use?
Yeah, that's a good question. I think that um, the biggest single worry is what we discussed earlier of the hallucinations, and one of the issues there is the context window. So, for example, when you're doing this activity that I was doing, I would generate, some very large files. Like I would generate a single file which had, maybe 1,000 pages of SysML v2 code on requirements, let's say. And basically that was beyond the capabilities of ChatGPT to handle. So it would have great trouble with that large of a context window. So what I did, I don't know, this is sort of my approach to trying to overcome that problem, was I generated many, many, many smaller documents. And then I would ask, and I would, based on the task list, I would ask, which of the smaller documents do you need to look at to handle this query? And then I would say, okay, then I would load up, let's say it would generate, 3 or 4 smaller documents. I would be able to load up the smaller documents and then get my query answered properly. So like I said, the biggest problem I had was the context window, that the files got so big. I learned by trial and error that the files were too big for AI to handle. And so I had to break them down into smaller files, and that wasn't really a problem. It was all very well structured. So, for example, in my task list, I'd have a file for each task in the requirements directory. So I would have 27 files, and each of those files was a specific task, and then the files were manageable within the context window of ChatGPT.
We don't have any more questions, so maybe what we'll do is transition to more of a two-way dialogue. So rather than be a traffic controller here, I just invite people to unmute and give us your comments, give us your questions.
Yeah.
Sorry, go ahead.
Sorry, go ahead, Ivan. I have a question after that.
No, I was just going to say if people wanted to go through the case studies, maybe that's something we could do as well.
Okay.
Okay. Yeah. So maybe quick question before that. Could you elaborate a little bit on your conclusion about the fact that AI lower the learning curve for SysML v2? My question being, by providing a way to use natural language, it makes MBSE easier, but I'm not sure I see how it is actually helping the user to learn SysML v2 itself.
Well, yeah, like I said, definitely the natural language idea is a two-way street. You can generate natural language results to queries, and then ask AI to generate the SysML v2 from the natural language result. And you can also go backwards and say, okay, given some SysML v2 code, can you generate natural language interpretations of that? I think that's a helpful way to learn SysML v2, to be able to go back and forth with natural language and see how SysML v2 would program it.
Understood. Thank you.
Mm-hmm. And it is effective. I've done that with previous versions of SysML, and not without some difficulties, but yeah, going both directions, it works. Yeah, well, we do have, let's see, 12 minutes left. So Ivan, if you wanted to dive into the case studies, I think that'd be a good use of the time. Oh, wait a minute, before you do, Sampath, you've got a question. Did you want to unmute? Go ahead. Oh, I saw a hand go up. I guess it's back down. Okay, go ahead, Ivan. Let's take a look at your case study here.
It might take me a little while to find it. I'll see if I can find it.
Are you able to hear me now?
Oh, yeah. Yes, we can hear you.
All right. Sorry, I think there was a little bit of a trouble with my microphone. I apologize for that. Thank you. I think this was a very, great preview and a good, probably in my case, a starter into using AI and AI agents. One of the key parts with agentic AI and off late is that you need to build a lot of context, and you kind of touched upon it, but I was curious to learn if there are like concerted efforts where you're pre-training some of these models, like creating an agentic AI which is specialized in model-based systems engineering, SysML v2, and topics such as that, and they come pre-trained for doing this kind of work. So is there any, are you aware of any work in the open literature which is looking at creating these agentic AIs, or the approach is to use standard large language models, which are pretty common nowadays? I think ChatGPT, we have Google's Gemini and Anthropic from Claude from Anthropic, and you use that and provide a context window to do this kind of work. So which approach do you see going forward is something that, will be prevalent with systems engineering and SysML v2 in particular?
Yeah. Well, I personally, my experience with Gemini and some of the other AI AI systems hasn't been great. I found that ChatGPT gave me the best support for what I wanted to do. But yeah, one of the things that ChatGPT has is an, I don't know what it's called. It's like an app. So basically, you can generate your own custom AI, and I think that could be a real way to exploit, like what we talked about with domain knowledge and other specialized applications of AI. So my advice would be to look into the customized AI agents that you can develop in ChatGPT. Does that help?
Yes, it does. Yeah. Thank you very much, Ivan. Appreciate it.
Okay. Do you have your case study queued up?
I have. Which case study would you like to see? I have two. I have a photovoltaic system, and for the sustainability working group, and I also have a medical device for diabetes, and the medical device has more has more work done on it, but I don't know. It's up to you.
Okay, well, we have just under, let's say, let's stretch it to 10 minutes.
Okay.
What would fit better in a 10-minute window?
Uh, maybe the photovoltaic system.
Perfect. Okay.
Okay, let me share my screen.
You know, we could, and possibly we can gauge the interest. Maybe we could have another session to go to really do a deep dive on your medical device case study.
Yeah, that like I said, I have a team of people working on that, and
Hmm.
we're working quite intensively, and we have a very long-term plan to do, to do prototypes and to do do human testing, and to also try to interest the company in developing the wearable device and marketing it. And so, yeah, anyways, it's a long-term project. So, but I can definitely give you a progress report. So let's take a look at this. So
All right.
this is for the sustainability working group. So this might be very interesting to people who maybe don't know about the sustainability working group, and it's an INCOSE group, so you may want to join it if you're not already a member. So the idea here is we wanted to have like I said, I only did the conceptualization phase, and so the idea is we wanted to the standard the strategic goals were to exceed these standards, and there was very good standards for circular economy and solar systems, and they were something that we wanted to exceed, and then we wanted to deliver reliable, low cost renewable power. We wanted to cut emissions and support the circular economy. We wanted to ensure ethical sourcing and fair labor, and we wanted to create lasting value for all stakeholders. So this is sort of similar. I've already mentioned this in the earlier presentation, but as I said, one of the things, like I said, we didn't get into in the earlier presentation was these last two phases: the operations and maintenance, and the retirement and disposal. And these are very important phases for the sustainability working group. And so I've developed the task lists for those phases. I haven't actually run through the process of that, but still I do have the task list. So here's the conceptualization again, and we did all this already. Here's the workflow. Here's the example of how I did it. This is again what I already talked about. This is conceptualization. I don't think so. This is the output of the stakeholder task. So there was various stakeholder categories: standardization, certification, government regulation, technical engineering, manufacturing, supply chain, deployment and operations, monitoring and verification, end of life and circular economy. So that was the community and ethical interests. So those are the key stakeholder categories, which was an output from one of the tasks. And then, oh yeah, we have financial and investment agencies as well. So, and then we have the needs. So we have this is the top level needs: regulatory compliance, modular, verifiable design, ethical circular supply chain, safe, cost-effective operation, financial viability, environmental impact reduction, equitable community benefits. And here's the mission statement that we generated using AI. And it's a little long to read, but I'll do it anyways. So we want to design, deliver, operate, and retire a photovoltaic power system that meets international standards, delivers reliable, cost-effective renewable energy, supports the circular economy, reduces environmental impact, ensures ethical and equitable practices, and creates transparent long-term value for all stakeholders across the life cycle. So I think that's quite a comprehensive mission statement. And then we get into the success measures. So these are I guess sort of parametric models. So we have the different success measures quantified, and so these are the different categories of the success measures and the goals that we're trying to achieve. And then we have the concept of operations. So we have the purpose and scope, and then we have system highlights. So this is the goals, the targets, and the connections that we want to have in the system. And we have the life cycle phases, and we have the key metrics, and we have the data and security issues. So that's the operations concept. I think this was just the outline of the operations concept. I don't think we actually wrote the operations concept yet, but I thought this was a pretty good outline. Oh, governance and validation, sorry. And then use cases. So we have safety and performance compliance. We have IEEE. These are the different standards: architecture and interoperability, sustainability, and lifecycle assurance. Environmental agencies permitting process. And then we have the context. So we have the system boundary. So here's the different internal subsystems. And then here's the external actors and interfaces. And then here's the primary flows of data across the interfaces. And here's some key assumptions. And like I said, all this was generated by the AI. And then risk categories, there was, I think, 45 risks that were identified. Here's the sort of summary of them. Non-compliance obviously was an issue. Technical safety was an issue. Environmental risks were an issue. Physical, financial and market access was an issue. So I think there were 45 risks identified at a high level. Oh, there's some more social and regulatory risks. And then concept phase. So this is a summary. So I think we're about out of time. So the concept phase accomplishments, we identified the stakeholder needs, the mission, the success criteria. We outlined the operations concept. We had some use cases drafted. We identified system boundaries, interfaces, and risks. And we looked at sustainability and ethics being embedded in the concept. And then we had some artifacts. We had some conceptual models like the needs and use cases. We had an outline of the draft of the concept of operations. And we had a concept level requirements and a risk registry. And so I guess I said this was a successful AI assisted modeling trial. So this is, I guess, what we hope to do next. So we want concept review initiated before requirements definition phase, and feedback. I'm requesting feedback from the sustainability working group on this, and then we want to have alignment with sustainability goals and ethical design, community impact, and life cycle compliance. So that's what I've done for the photovoltaic system. Next steps is do the requirements definition, and then, like I said, I'm looking for support from the sustainability group, working group, to continue this work. Concept phase completed with clear system definition, embedded sustainability principles. Project is well positioned to enter requirements definition with a strong foundation. AI assisted modeling enhance the quality, traceability, and efficiency of conceptual artifacts. That's the case study.
Excellent. Thank you. Does that spawn any additional questions? No. Okay, we're at time. I'll give it another second here. No, nobody. Okay.
Okay,
Thank you, Ivan, for
Yeah.
sharing. Very much appreciated.
Yeah, thank you for the great questions, guys, and like I say, I'm very interested in connecting with anybody who wants to do this. And actually, Ivan and I are thinking that maybe we'll do a tutorial on this later in the year. So
Yes.
maybe the Canadian INCOSE chapter might be able to set up maybe a 4-hour tutorial on a Saturday afternoon or something like that.
That would be good. Yeah. Yeah. So just watch for some emails. We'll maybe do a survey or something to gauge interest. Yeah, I would most definitely partake in that, Ivan. Okay, with that, I will close. Again, this session has been recorded, so you can look back to the recording on the INCOSE Canada website. And for those of you who are attending either in person or virtually the International Symposium in Ottawa, a few of us, Stefan and myself, will be there. Unfortunately, Ivan won't be there in person, but do reach out to us and say hello. Introduce yourself if you see us at the symposium. We hope to see you there. And lastly, there is also in Ottawa prior to the symposium is the transportation infrastructure workshop. So I have that up on the screen right now. If you do wish to register, please do so. You can go to the INCOSE Canada website to get the registration link if you don't already have it. With that, we'll close. Thank you very much, everybody, for attending, and have a great evening. Bye for now.
Thank you. Bye-bye.